Welcome back. This is lesson 17.3 and it's the last in our short series about computational methods. In this lesson, we'll look at the final few computational methods. In this lesson, we'll look at performance modelling, pipelining, visualization and pattern matching. I'll briefly review what each of these means. Performance modelling means using a simulation to test a system or an algorithm. This is much cheaper and safer than trying things out in real life. You can try out as many scenarios as you like using a wide range of test data. It's quicker, safer and cheaper than running software or other systems for real. We use performance modelling a lot in the design, for example, of buildings, bridges, so that we can test them out, that they won't fall down before we build them. And we also use performance modelling to help to train people to do dangerous tasks. In the Computer Methods workbook, I have an example of a question relating to performance modelling, and it's shown on the board. Could we use performance modelling to plan out how to put the cabling into a college? Why would that be better than trying it out for real? So try and write an answer to that in the book. Remember the checklist, show your understanding, apply it to the case study and evaluate the options. You can pause the video now and have a little go at that. The next method that I want to talk about is pipelining. Pipelining is a situation in programming, a method in programming, where the output of one function is fed through as the parameter or argument for another function. So it's a way of speeding up the process of computation by passing values at speed through a range of functions. The output of one process becomes the input to the next process. This can't be done, of course, if activities are done concurrently. So in a previous presentation, we've looked at the advantages of concurrency, that's doing things at the same time. Pipelining is another method that is contrasted with concurrency. You can either have one or the other, but they're both ways of making programs quick and efficient. And obviously pipelining can be automated, that is, we can build it into our programs that the outputs of our processes are passed along a kind of pipeline of different functions. And just as concurrency can also be used in team working, so pipelining can be. So we'd have a series of people doing tasks and the work is being passed along the chain of people. And this is a way of speeding up production or any task that needs to get done. So once again, pipelining is in contrast to concurrency. Concurrency would be a bunch of people all working at the same time on independent tasks. Pipelining would be a line of people passing work along between them, and both are ways of working quickly, whether inside the computer or in a team. So have a think about this. How might pipelining be used to get a video game out in time for Christmas? I'm thinking here particularly about pipelining in team working. So see if you can write some ideas about how a team might work together using pipelining. Visualization is a slightly different form of computational method. In visualization, we are asking the computer to present the data to us in a human readable form so that we can spot patterns and make decisions. So it's a little bit different from some of the methods that I've been talking about up to now. It's the computer supporting us to make our decisions using graphs or maps or diagrams. So here are some examples of different ways that we can use colour and design to present data. And obviously people drew graphs and maps before computers came along. Computers are just a tool that we can use to improve the visualization of data. So here's an example of a map showing some use of colour to indicate how earthquakes may be more or less likely within an area, and your task is to write a short answer, maybe write for about 10 minutes, evaluating the way that visualization could be used to help people to understand the prevalence of earthquakes. So remember, you have to show that you understand what visualization means. You have to explain how visualization would be applied to this problem, and what are the good and bad aspects of using visualization for this purpose. And finally, the final method that we're going to look at is called pattern matching. In pattern matching, the computer learns a pattern. We might, for instance, have a database of patterns that we want the computer to recognize, and then it can recognize data that matches this pattern. Pattern matching has a lot of good features, but it can't be used, unlike some of the other methods that we've talked about, to deal with new or unexpected data, because the computer is referring to patterns that we have already recorded. So pattern matching might be used to identify fingerprints, or to play games, to catch spam, for security, facial recognition. All of these are examples where the computer is looking for patterns that it already has recorded. So how might we use pattern matching to predict the presence of viruses hidden in computer files? Once again, reminder, understand, apply, evaluate. You can pause the video now and have a go at that. So to recap, we've learned what performance modelling, pipelining, visualization and pattern matching are. These are all techniques that we can use to solve problems, and in all cases these things can be done without computers, but computers are a useful tool that help us to apply these kind of computational methods to a wider range of problems and get an answer more quickly than if we had to do it all working it out on paper. There are some remaining questions in the workbook if you're my student, and as I say, if you're not my student, have a look at the exam papers put out by the exam board that you're working with, because you'll see what kind of questions they ask about computational methods. Okay, so that's a short series of 3 lessons that we've had on computational methods. In the next series of lessons, we're going to go back to actually writing computer programs. So I'll see you then. Bye for now.